Okay. Hi, everybody. We're very excited for this next session. We're going to be hearing about communication around heat risk, right? A theme that we've been discussing a lot throughout the workshop. Certainly, we heard Chris Ebi highlight the importance of communication as a leading step really in thinking about resilience. And in light of all these complex emerging risks, obviously the communications issues include a blend of low-hanging fruit, but also vexing complexity. So it'll be interesting to engage around some of those topics in this session. Kicking us off, delighted to introduce our first speaker, Andrew Pershing from Climate Central.
All right, thank you. And hey, before I get started, could we give a hand to the crew in the booth? I feel like the AV, other than this remote control, which nobody can figure out, I feel like the AV has just gone amazing here, including like the remote stuff. And also, I really dig the playlist before the meeting. All right, so my name's Andy Pershing. I'm going to talk about our operational attribution work. Before I do, I just want to introduce Climate Central very quickly. We're an independent nonprofit research and communication organization. We are loosely based in Princeton, New Jersey. This is our motto, science made clear, climate made local. What we do is take science, including some of the science that many of you do. We try to translate that, package it, and produce it into a format that is easy for people to digest, especially the media. A big part of our strategy is to make it very local, so to try to connect climate change to the local experience that people are having. I like to say we want people to touch, feel, taste, and smell climate change in the world around them. And if you think that this sounds like an exciting thing to do, and it is, please consider applying for our position as VP for Science. You can find it on LinkedIn. You can hit me on LinkedIn, or I'll put my email up at the end, or you can just Google it or go to our website. All of you know how to do that sort of stuff. Okay, so like many of you, when I was starting out as a baby climate scientist back in the early 2000s, this is what we were taught, right? That no single weather event can be linked to climate change. And then, fitting with this meeting, right, we started to get attribution studies, beginning with the European heat wave study that came out 20 years ago this year. We then move, after a few years, World Weather Attribution comes into the picture. They are now doing operational attribution studies. Rather than doing it in more of a research or academic mode, they are taking the techniques that were developed in the scientific literature and applying them to events after they've occurred. So picking out some of the most impactful weather events around the world. There we go. Okay, and then by 2016, right, the National Academy of Sciences came out with a report on rapid attribution, really gave the seal of approval to these rapid attribution techniques. And the National Academy is actually going to be reviewing attribution again, and there's a call out right now for folks to participate in that. So we really feel like the narrative has shifted so that now rather than being, no single event can be linked to climate change, it really is that climate change is a factor in many weather events. And the question is really, can we quantify it? And I think that quantification is really helpful. And that's what we have built our Climate Shift Index system to do. So you can access it at csi.climatecentral.org. You can do things like look at this map. This is the map not of today. This is actually the map for Sunday. So we're using the NOAA Global Forecast System. We're looking out a couple of days. So the forecast for Sunday, you'll notice a lot of red, a lot of warm in the country. No surprise. And then we were able to then turn that into a map of an attribution metric that we call the Climate Shift Index. So anywhere that is dark red, we are saying that those temperatures are 5 times more likely because of climate change. Right? Yellow is detectable, right? It's 1.5 times more likely because of climate change. And we have a few gray areas like you see in Mexico where climate change is making those conditions less likely. Those are conditions that are becoming less frequent in today's climate. This is a really scary map, and the maps have been very scary this summer. So how do we do these calculations? So we begin by taking the normal climate, the 1991 through 2020 climate, based on ERA 5, and we do this for every location on the ERA 5 grid, and we do it for 24 periods throughout the year. So we characterize the frequency distribution of temperatures. We then, at that location, will look at how that period of time's temperatures has historically responded to changes in global mean temperature. Essentially, what is its local climate sensitivity? Once you have that local climate sensitivity, we call it beta, you can then shift that frequency distribution up to simulate going from the 0.8 degrees, which is about the average condition for the 1991 through 2020 normal period. We have to warm it up to our current climate of about 1.3 degrees Celsius, and then we can cool it down to a hypothetical counterfactual no global warming climate, right? A climate that does not have the human influences from greenhouse gases. And then you look at that day's temperature, and we take the probability ratio of how much, with the ratio of the likelihood in today's climate versus the counterfactual, and we take the log of that, and that's because we can take the averages of the logs, because we want to do this in several different ways. That's a key part of most of these attribution techniques, is trying to really bring in as many lines of evidence as you can. So we also use 24 paired climate models from CMIP6. So each of those, we have the forced runs and we have the unforced pre-industrial control runs. And so from those, we get from each of those paired climate models, we get those two distributions. So that gives us 24 measurements of this log2 of that probability ratio. And then we average those together. So we take an average of our two. We actually have two empirical methods that are slightly different. We have then our average of the models, and then we have the average of the averages, and that's what. And then we turn that into the climate shift index. And so, of course, these numbers are continuous. We made the climate shift index into a discrete scale, -5 to 5. Because we felt like that would be more effective for communicating this, and we did work with some different folks, including some of the broadcast meteorology community, to test how they would be able to talk about this. Okay, so how are we using that? So in addition to the map, we have a team we call Heat Squad, where twice a week we are looking at the forecast. We are trying to identify heat alerts around the world before they occur, and then we try to package that up as an alert that we send out to the media, not so much because we want people to cover the alert. The news is not that Climate Central made the alert. The news is that the heat happens, and what we're trying to do is create a permission structure for people to talk about the impacts and consequences as the event unfolds and be able to link it back to climate change. So here's an example for one we did for the Eastern Mediterranean, and then another one earlier in the year for the Southwest. We now have the problem in the United States that we cannot define events. The map is blurring together. So the lines are blurring in space and time. So it is very, very hard for us at the moment to define events. And that's something that, when we started doing this last year, that we didn't really face. And so it's kind of a new challenge for us that we're trying to work our way through. We also do reports. For example, we did a report, a look back on the 12 hottest months, what at that point had been the 12 hottest months through November of last year. We also are doing seasonal analyses as well. And so we can get graphs like this, or maps like this, where the first half of, essentially the first half of 2023, 58% of people around the world had experienced 10 or more days at climate shift index level 3, essentially 10 days where their temperatures were 3 times more likely because of climate change. You can think of this as an exposure metric for people's contact with climate-driven heat. By the second half of the year, it was 82%. You really see the surge in temperature around the world that happened in the last half of 2023. So I'm going to talk very quickly about some of the other ways that we think that this can be used, and this is putting a little bit more on my science research hat on, and that's how we want to try to do attribution around impacts. So let's say we have a location and we have a record of temperature here, and this is our observation or our modern climate observations. And let's suppose that we have a model. So maybe some of the models like we were seeing around that translate in mortality risk as a function of temperature. If you have a model that is a function of temperature, you can then hit it with the observations, and you get what the model says that process should be, right? The prediction from the model of that process going out through time. While publicly we're communicating about the likelihood ratio around every day's temperatures, we also can sort of flip the calculation around and come up with counterfactual temperatures. What would the temperature have been in a world without climate change? And so you can then take those temperatures and run them through the model, and now you get the counterfactual version of the process. And if you take the difference, that's the attributability of that that we have in that process. Okay? And so while we've been talking about air stuff, I'm going to talk about the ocean, because in a little less than a month, we're actually going to launch our ocean temperature attribution service. And so I'm going to show how we can apply this logic to coral bleaching. So the coral bleaching model that NOAA developed is a degree heating weeks model, where degree heating weeks are defined against the local maximum monthly temperature at that location. So hot reefs, historically hot reefs have a higher threshold than reefs that have been cooler. And then we also then take a 12-week mean, and that's what they use as their indicator of coral bleaching risk. So if we look at our maps, and this is for 2023, so picking just a particular day in October, kind of at the end of the heat season in the Caribbean, you see that there were a lot of degree heating weeks, up to 10, over 10 in most places in the Caribbean. And then in the counterfactual world, ready for it? Ready for it? Okay, there we go. Almost nothing, right? Almost nothing. This is a really important thing. Jacques Cousteau, all of the diving that he did in the Caribbean, never saw coral bleaching, right? It did not exist until humans started messing with the temperature of the planet. So we can then take the difference and look at the attributability of those degree heating weeks. So that's the scary red map on the right. We can also integrate this. So now we're going to integrate this across the Caribbean and look at the change through time. And now that I'm looking at over 2 years, 2022 and 2023. So you see the surge in temperature in the Caribbean in 2023. These are the risk levels that NOAA defines based on the degree heating week metrics. You can see, in 2023, we really were pushing basically the whole Caribbean up to the extreme level of their alerts. And then we add the counterfactuals, and you can barely see them, right? Coral bleaching is essentially 100% attributable. It would not happen without human-caused climate change. Okay, so on a happier note, here are all of the links that we have where you can access some of our materials. So the Climate Shift Index map is at csi.climatecentral.org. We're going to be launching a similar map for CSI Ocean beginning in, we're going to do it, I believe, on the 14th of August. We also have a 1970 through present hindcast where for every day we're calculating the likelihoods, the likelihood ratios, and the counterfactual temperatures for daily high, daily low, and daily average temperatures, and also now sea surface temperatures. This is something that we are going to be releasing publicly, but if you have a specific application for that, please email me, and we will try to figure out how we can help you. And then, of course, please consider signing up for Climate Matters, which will be the topic of the next talk. So I have a couple of minutes, I hope, if people want to talk.
Yes, thank you, Andy. Do it. Yeah. We do have time for at least one question, maybe two, if it's a quick question and quick answer.
Great talk. Thank you so much. I'm curious about the process through which you guys decide what products to develop, and how do you think about who's the user of these products? Could you speak a little bit to that process at Climate Central?
Yeah, great question. So we a lot of our strategy has been informed by our experience, and also, for example, research with folks like folks like Ed Maybach at George Mason and Tony Leserowitz at Yale. So really trying to understand how the public processes climate information. So that's really informed our strategy of trying to be local, trying to work with especially the broadcast meteorology community that Bern is going to talk about. And then it's about trying to find products that provide these communication opportunities. So daily attribution, it's something that you can talk about every day. You can talk about it in the summer, you can talk about it in the winter. It's a way of kind of bringing climate change into the story and bringing it into the weather conversation, which is a conversation that most of us have every day.
Awesome. Thank you so much.
So do you introduce any kind of climate uncertainty in your climate shift index? And if so, how do you communicate that?
Great. We do have uncertainty calculations. We are publishing them on the research side. Communicating uncertainty is very difficult to the public, so it is not part of the public-facing communication on this. We have tried to, our approach, because we don't want to have to put confidence intervals on everything we do, right? You don't see a lot of confidence intervals in a weather forecast. What we've done is create our scale in such a way that we think it's fairly conservative, so that the idea is that we want to come out with a number that says 3 times more likely, 4 times, 5 times more likely, and then if world weather attribution, or if we come in and do a more detailed study, we want those numbers to be higher on the second try than in our first estimate. So we really are trying to be conservative in the way we've put the numbers together.
Great. Thank you, Andy. For our next talk, we're going to stay with Climate Central and hear from Bernadette Placky.
Thanks, Andy, and everybody. And I would like everyone to give a round of applause to the organizers for bringing this great group together. They've done some amazing work. It's always so valuable and energizing when we can bring people from different areas together to have these conversations, and it usually does show up in future collaborations, which is a big part of the work that we do at Climate Central, and it'll show up in some of this presentation here too. So what I'd like to do is show you a case study of Climate Matters. Now, this is a program that was started in 2010 with a whole collection of people. Louis, who was just up here, works at George Mason University, and his colleague, Ed Maybeck, has been a colleague on this project since the beginning. Also, from the beginning, there was Yale, American Meteorological Society, NASA, and NOAA, all partners in this project. And why this is important is we're talking here about how we're advancing knowledge and actions. But we need to connect with the public. They're a big partner in keeping them safe and prepared and keeping them informed. So that's why something like this is important. And what we've learned from it, I'm going to bring to you too. So starting out with Climate Matters here, the whole concept of this was early research by Ed Maybeck looking at who is a trusted messenger when it came to climate science. And TV meteorologists were at the top of that. Now, for a few different reasons, we leaned in on this. They are trusted messengers, but they also are uniquely positioned. They have ongoing conversations with their audience every day, and they have this ability to reach across the spectrum. People are interested in weather. They weren't always interested in climate, but it is ultimately connected, and they're on the front lines of that changing weather, so they can make the connections. And the public really is looking for answers. The narrative of people not caring about climate change is old. It has changed, and I'm going to show you that in a minute. People want to know, and so they have an opportunity to answer those questions. So in 2010, when we launched this, there was some public research done around this, and you can find that online, or I could share it with you, that as we brought local climate information into a broadcast in a way that was timely and relevant to the audience, the people were concerned, and they learned. And so fast forward over the past 10 years plus, we launched this as a full-time program across the country. We now produce content weekly across the country. We do some international work too, and you saw from Andy there. We have global tools at Climate Central, but what I'm going to go through has been pretty U.S. focused here. We started Spanish translation because there's a lot of Spanish language media in the United States too, and we want to support them. Began supporting a global TV weather presenter community heading into COP21 and the Paris Climate Change Agreement. And then we expanded to journalists more intentionally with another National Science Foundation grant in 2017. We also have launched some really interesting tools along the way too, one being Weather Power, because weather's not only impacted, it's also a solution to our climate change. Wind, solar, water. And so that's a tool that we've created in the process in addition to the Climate Shift Index. So a summary of some of what's happened over that time is when this launched, only 54% of the TV meteorology community were even convinced the climate was changing. That doesn't mean they were all against it. A lot of people just had questions, and they didn't know where to go for solid information that they could trust. And there was a lot of misinformation coming at them. So we were able to connect with them, help them understand and become their trusted messenger in the process. And by 2017, that number had already jumped to 95%. And now TV meteorologists are some of the leading climate communicators in the country. This was an Atlantic profile done What's really interesting right now, showing this slide, is that this is Shel Winkley, and he just started working with us a couple of months ago. So we've brought him over to the Climate Central side now, too. Now, if you're interested in diving a little bit deeper, we do have published research on this. We did a public impact study on the entire program and showed that, again, on several different climate metrics, as people learned about this in timely local ways that were relevant and science-based, that people's concern metrics went up on several different categories. And we did this in a closed study, too, with 2 different audiences in Miami, both in Spanish and English, and in Chicago. Again, people were interested and they learned. So there are ways to do this. And Ed has even taken this to another level and really put this in a paper about how we can advance climate understanding by supporting communities of practice and taking through a case study of what we've learned through this program. So why does this matter, right? Well, people are concerned. They do have questions about what's going on. And a lot of you know this research, but I never like to just assume. So Ed Maybeck and Tony Leiserowitz, who have already been referred to here in the last one, they've put together the Global Warming 6 Americas. Now, I mean, this is advanced to many different countries too, but 6 categories of how Americans look at climate change. And this is ongoing research done twice a year, going back to 2008. And consistently, we see these 2 bubbles on the left continue to grow. People are alarmed. People are concerned. They just don't always understand what that means to them and their community or what they can do about this. And that group on the right, the dismissive, that's only about 10%. It's fluctuated a little bit, but it's really hung around that 10% mark. They've been given an outsized voice, and it's driving a lot of the conversation around climate change. But 90% of people are at least open to hearing about this or learning. So we have to remember that when we get into communication. That is really critical. You don't want to cater to just the 10% when there's 90% that genuinely either has questions or wants to learn. And when this has been distributed around the country, people might say, well, not in my area, but that's not true. This is data that shows across the United States, people are overwhelmingly convinced this is happening. Again, they just don't know what exactly that means, how this is being created, what they can do about it. And if you go to this research, Yale Climate Opinion Maps, there is a button at the top, and when you drop it down, it'll show you, there are about 20-some questions that they consistently ask. You can look across different geographies, and you can look at timescales of how this has been tracking too. So here's 2 more that I wanted to show out that stand out for me. If this is really our biggest challenge, and people aren't even talking about it, we've got an issue. Right? This is a big issue. And look at this one. Teaching the causes, consequences, and potential solutions. Over 70% think we should do that across the country in areas where we're even banning books and banning other things in classrooms. People, to me, this shows people want to learn. So we should lean in on this. We have science on our side and public opinion on our side. So we shouldn't run away from this subject. So with all of that in mind, here's an example of how we've been doing it. And this is all stuff that you guys are welcome to take and bring into all of your communication. So Climate Matters really looks at this through 3 distinct categories: education, content creation, and our network support. Our education, we had to really listen to our community. Where were the barriers? What were they not understanding, or where were they getting confused on certain things? So we're constantly doing webinars, going to workshops, conferences, hosting things. Content creation. We put out a weekly package of the localized data and put together in ways that people can consume what we're telling them and what we're explaining to them. What is the latest on the science around a timely topic? We've got graphics on that. We have experts. Some of you have been our experts. We're willing to be interviewed on certain topics. And then our network support. We have so many people coming at us with so many different questions that are really trying to advance their own knowledge and their climate storytelling. And so this pops up in many different ways. For example, during the session yesterday, I had to stop, walk out and do an interview with WCBS and then come back in during the panel yesterday. So they just they have a lot of questions. They want to do different things in different ways. And so we're always trying to support them in their journey. And here's a snapshot of just some recent heat-related content. We do a lot of different things, but we do a lot with heat. And so from summer warming trends across the country, and we have this for over 240 local cities in the US too, when we do produce local. So a lot of places around the US. You see example of more warm summer days for Miami. I mean, more than 40 in just the summer? This is a humongous change. Then you're looking at Reno, days above 95. Now that's when we're really having to rethink life, right? How we organize life. Do we go to camp? Do we get the kids in an outside practice? How we have to organize our day. The combination of hot days and hot nights. We've talked about why that's important. Not getting a break for our bodies, not getting a break for our air conditioning. And that is on the rise. Look at that in Austin. Almost more than 2 more weeks of that. Then we do a lot of explainers too. This is one of my all-time favorites, so I'm always going to show it. If you've seen me before, you're probably going to see this again. I just love this one because people say, what's a degree, right? Well, it puts you in a whole new zone of what can happen in your world. And that's why that's so important to try and understand. And that plays out so many different ways. I won't go into depth. We've already covered the importance of the extra concentration of heat in our urban areas. We just this week released an update on our urban heat hotspots, really getting into the granular level of 65 of the most urban areas in the United States and an explainer around that. Also increased cooling demand from the cooling degree days, it was explained yesterday. And then looking out in time in consumable ways of what does it mean for a couple of degrees in the summer? I mean, we fluctuate 20 degrees a day in some areas or more, but how that puts you in a whole new category of how you have to think about life. So we apply that to health. Obviously, one of the big ways we're experiencing this, bringing in many of the moisture factors that have been talked about today. When we can get a good data set to localize it, we like to bring that out. We worked with your team, Radley, one time to recalculate a research project that he had done that was globally to bring it to more US-specific metrics. And if you have cool research coming out that you think can fit into this, work with us. We want to get this out to people. And we're doing a series this year on a focus on kids' health. So we've got a 5-part series. The first was on allergies. The second was on heat and how this is really affecting kids. So what we've learned, and I think everyone can take into their work regardless of what you're doing here, and even just in your conversations in your neighborhood, is know your audience. This is the golden rule of communication. Consider topic, timing, tone in how you bring something out. We can get really geeky in this room, but most people don't care the same way we do about this science. So we want to bring this in a level that they're interested in learning. And I always brought this when I was a forecaster on TV. Someone had told me, it's like you're talking to your grandmother, right? You have all the respect in the world. I mean, my grandma's not a PhD scientist, maybe yours is, but like you have all the respect in the world and you want them to understand what you're talking about. Then you want to meet people where they are. There's so much that connects us, and sadly, everything's being affected by climate change, and heat is the foundation for those changes. So we connect on those shared values and how things are changing in their lives. The power of personal and local. Again, 1.3 globally Celsius or 1.5, we get what that means, but most people don't. They are on the subway right now saying, I can't breathe because it's so hot down here. Oh my gosh. So that's personal, that's local. Tell a story when you can, if you're in an opportunity to, and don't be afraid. Again, you have science and public opinion on your side. So I know that I'm running out of time, but I did have, can I show one video or no? Oh, good, okay. Okay, so communication is a climate solution, and I want people to understand that. Now, I loaded up too, because I didn't know how much time I'd have, and this one I think is, this is Andy's favorite.
This morning, you needed a jacket. It was chilly. Briefly, Albany dropping down to 37 degrees. Typically 48. That's the low we would normally expect this time of the year. Well above the record low of 31, which stands. It's set back in 1977. CSI index of -1 here from our partners at Climate Central. This is the Climate Shift Index, an attribution tool where we can look at low temperatures, high temperatures, and average temperatures and relate it to how climate change is affecting those temperatures. And a -1 CSI means temperature 37 on this date, this time of the year, is made 1.5 times less likely to occur as the climate warms. Of course, we are going to have chilly mornings with a warming climate, but what we are seeing and what we will see in the future is that the chilly mornings like this will become much less frequent, and the magnitude of the chill, which was the case today because we weren't even close to a record, will continue to decrease with time. And this, of course, all due to the increasing amounts of greenhouse gases in the atmosphere. I will tell you this, though, Thursday morning is likely to be chillier. In
This is
fact,
the wrong video I loaded. I'm
for
sorry.
frost and freezing.
He had a really good one that I wanted to show you. So that was good too. But he did one that was so great where he connected the wildfires last summer out west in Canada to what he was experiencing in Albany, New York, and used Climate Shift Index to do that. And then if I do still have a minute, I'll show just a quick summary of this one. This is like a quick snapshot of a lot of what people are doing around the country to give you a sense of how this is playing out.
Let's take a look at the Climate Shift Index. This is a tool that helps us to kind of indicate whether or not climate change has influenced local temperatures.
We're at a 1 out of 5, meaning our high temperature is 1.5 times more likely tomorrow because of our changing climate.
How likely is it that climate change has its real grip on this? Pretty likely when you're up at the scale here at 4 or 5.
We're already pushing number 5 there. That's way on the edge. That shows you these are the fingerprints of climate change.
How does this tell us about the impacts of the change?
Right, so if we know that these temperatures are more likely because the climate is warmer, that can tell us about conditions like heat sickness.
Very, very hazy or milky appearance to the sky. And of course, this is all originating from the ongoing wildfires here across Western Canada. And there's most certainly a climate change link.
An alarming new report reveals Earth just had its hottest 12 months ever recorded. Researchers at the nonprofit Climate Central analyzed global averages and temperatures from November of last year through October of this year, and they found they were about 2.4 degrees above pre-industrial averages.
It has the fingerprints of climate change. A study was done by Climate Central yesterday. The heat wave we are currently in is 5 times more likely because of climate change.
Localidades como Carolina del Norte y Virginia están experimentando 4 veces más cálidas temperaturas que el promedio.
Today's extreme heat brought to you by man-made climate change. Extraordinary hot temperatures like this are made 5 to 10 times more likely because of how humans have altered the atmosphere by burning fossil fuels and enhancing the Earth's natural greenhouse effect. It's just not usually this hot this many times in the summer.
So, thank you.
It was great to see, and thank you, Bern. We don't have time for questions.
I'll be here so we can talk at lunch.
Yeah, okay, great. So let's move on to our next speaker, Kathie Dello from NC State.
The green button. I did my undergrad in Albany, so I'm always happy to yield some of my time to Steve. He's fantastic. But yeah, I'm going to talk a little bit more about some of the work that we're doing in North Carolina. So getting to the local, being a really trusted messenger. I'm the state climatologist of North Carolina, and essentially that means I help all 10.5 North Carolinians understand their climate risk, and I do that by working with state and local governments. Now, it's hot in North Carolina. This is not disputable. It is a hot state, and a lot of the norms around how we gather in North Carolina are because our summers are hot. We have sweet tea, we have fans on our porches, we spend time outside to cool down. We don't have what you have in Portland, and I spent a lot of time in Oregon, so thank you for taking care of a state that means a lot to me, but we don't have a blockbuster heat wave to point to and say, this is something you really need to start paying attention to because North Carolina has been hot. So we're trying to tell folks that this isn't your grandmother's heat, this isn't your mother's heat, this is a new kind of heat. But heat doesn't affect people equally across the entire state. We have a very nice mountainous region, and some of my colleagues from Asheville are here. Stays a little bit cooler. We have the hot Piedmont area, which is where our cities are located, Charlotte and Raleigh, and the coast gets pretty hot too. North Carolina is the 5th most visited state for tourism, and they are often going to these really hot places. These are people from Maine and Minnesota who also aren't used to the Carolina heat that we have now. And I love being in the South. It's incredibly fun, but there are 108 phrases for how you can talk about heat in the South. None of them are appropriate for mixed company. So we just continue to say it's hot, y'all. Now, the 5th National Climate Assessment, and I was an author on the Southeast chapter, did a really nice job at kind of tying together the social factors and the climate factors. We put a really strong emphasis on equity, and we centered that front and center in our chapter. And we looked at energy-burdened households and communities of color, so that's the map on the left, and just the projected changes in extreme heat days on the right in the Southeast. And they correspond very, very well. We know, we've heard this for the past few days, that the people most burdened by heat are often the lowest income communities of color. And we know we have compounding issues. We've been talking about them for 3 days. And we looked at the National Climate Assessment. We took blackouts affecting more than 1,000 residents for 1 hour by each state. And North Carolina during the warm season has an astounding number of events. We are very much at risk to losing power in very hot days. We're also very used to having air conditioning. It was difficult for me to be here on Tuesday and Wednesday because we are so air conditioned in North Carolina. And we're so car-centric that you are almost never outside. So the subway has some work to do here, but we are really dependent on that air conditioning for better or for worse. Now, we in North Carolina are a very rural state. Steve Kornacki, when we have the election, he'll pull up the counties and you'll see Mecklenburg, Charlotte, Raleigh, Wake. There are 98 other counties. They do not have chief heat officers. They might have a part-time emergency manager who is also the person who puts up the Christmas decorations on Main Street and manages every single aspect of what's going on in that county. And our counties came to us and said, we need help. We need help planning for heat. We know it's an emerging problem, but caveat, we don't want you to dump all of your models on us. We don't need all of your science. We just need you to take us a little bit further. And to this group, I want to say, when there's a bear chasing you, you just have to run faster than your hiking partner. And that's what we're trying to do with these counties, is run a little bit faster and help them out this year and help them out next year. So we're really trusted individuals. I get in my car and I drive to Kannapolis. I get in my car and I drive to Harkers Island. I spend a lot of time away from home, sitting down and talking with people, listening to them first and understanding their concerns. And this is how this project came about. We listened to Chatham County. Our colleague Ann Lowry called us up. Well, she called up my colleague and said, I really want to think about heat this summer and I want to be systematic about it. Can you help us with some resources? So me and my colleague, Andrea Webster, who is with the North Carolina Office of Resiliency and Recovery, which Governor Cooper started after Hurricane Florence and now is a permanent state entity, we were sitting in the back of a flooding meeting, so maybe not paying attention to what was going on, specifically with flooding. I assure you we are, but she turned to me and said, Ann Lowry in Chatham County wants some help planning for heat. She goes, what do you think about it? And I said, yeah, absolutely. We have 99 other counties. Can we do this in a way that we can scale this or bring folks together so that they can learn from each other? So we brought folks together exactly a year ago in Fayetteville, North Carolina. It's one of the hottest parts of the state. And these are local governments. These are county governments. These are folks from Duke University's Heat Innovation Policy Hub and state agencies. And we put together a draft heat action plan to walk through with them. And I say draft because we listen to folks, and if they tell us this doesn't make sense to me, or we need to do this differently, or this won't work in Orange County, North Carolina, because you wrote this for Dare County, North Carolina. And we walked through with them to understand how they could target some of their resources to people, and I'll go through the toolkit, but also what they really needed to help folks out. I think we get so focused on the big picture, and 2050 and 2100 people need help now. This was a really successful workshop, so we took all that feedback and we sat down and we got to work over the last winter. We know who's at risk from extreme heat. If you haven't been paying attention for the last 3 days, then here's the slide for you. But the toolkit includes, and please, the QR code will show up on multiple slides, so don't worry about having to scan it immediately. Information on why you need to prepare for extreme heat. So again, we have a communications challenge in North Carolina. Carolina summers are hot. They've always been hot, but they're hotter. Information about heat-related illnesses. Like I said, These counties don't have chief heat officers, they have part-time emergency managers, and their county health departments are strapped. There's an opioid crisis in this country, and it affects North Carolina. These folks are dealing with so many things that climate change is not the top of their list, and it's rarely what they're thinking about first. So helping them understand a little bit more about how heat impacts people. Funding opportunities, because we love to tell people to plan, but we never give them resources to do it. So we've connected folks with ways that they can get grants to support some of this work in their local neighborhoods and counties. How to work with external partners, how to call me up, how to work with state agencies, how to work in your county cohorts, and so much more. And after we had that meeting in Fayetteville, we came up with a heat action plan template. There are 31 draft actions to do during the heat season, from recording a message for your hotline, what to do when an extreme heat event is forecasted. And as we just heard, it's kind of all running together. It's been a very hot summer in North Carolina so far. And longer term strategies, not just thinking summer to summer. We would love for you to steal this, use this. This was all publicly funded. You can take it. You can cross North Carolina off and put your own state, work with your own counties to really develop this. But we hope folks are using it. And we also take feedback very seriously. If this isn't working for folks, we want to hear it. We also walk them through some exercises in identifying who's the most at risk in their communities and identifying thresholds for extreme heat. And we've heard a lot about thresholds over the past few days, and I'll talk a little bit more about that. This isn't meant to undermine the National Weather Service, heat advisories, or excessive heat warnings. The National Weather Service was a big partner on this project. These thresholds that we developed were using emergency department data and what we call NC Detect regions. And this is for county government's sake first and foremost. So we showed them the threshold at which people start going to the emergency department more for heat-related illnesses. That gives them a chance to activate some of the things in the heat action plan. It's not us sending out an alert ahead of the National Weather Service. I really want to underscore that. We work closely with our federal partners, but we know that we are a trusted entity within the state of North Carolina. And these are the thresholds that we developed. These are heat index. And like I said, at the very beginning, they said, do not dump all of your science and modeling on us. They did not want wet bulb globe temperature. They did not want local block scale modeling. They wanted it grouped by counties. They wanted it to be defensible so that if there was a boundary, why is it 94 in the mountains, which we know, to 101 when you're getting it a little bit lower in the foothills. So they are tied to our API in the state climate office. Anytime one of these heat index values is forecasted, the state health agency gets an alert, and then they send out an alert to their county partners. And it's been working really well. Again, we're in a pilot phase this summer. We also have supplemental materials. We recorded a webinar and we said, here's what's up with heat in North Carolina, community surveys, messaging, social media posts. And we really did take care to target the social media posts to folks in North Carolina. It's a different state than Oregon. It's a different state than Minnesota and Maine. And we really try to keep the culture and the values of our state at the center of everything that we do. And we're doing a number of things in North Carolina. We now have a cohort program who's working through the heat action plan, and we're just getting constant feedback from them, and it's a learning network for them as well. Integrating heat into hazard mitigation plans. We've thought a lot about flooding and hurricanes in North Carolina. Now we're thinking the same way about heat. We're updating protocols. We're doing heat-related illness surveillance and working on the heat alert system. And I don't think I have the cattle on here, but Nathan and I connected. Our cattle also don't like heat in North Carolina. And then Governor Cooper declared the last week of May Heat Awareness Week due to some of the work that we were doing with state, local, federal partners, the work that we rolled out with the toolkit. A proclamation is not life-saving in and of itself, but it helps to elevate the awareness of the issue in a state that's always been hot, y'all. So I think I have a few minutes for questions, but this is where you can access the toolkit again. Reach out to me if you have any questions about anything, and then Andrea Webster is the best contact at the state. Thank you.
Thank you, Kathie. We do indeed. We have like 3 minutes for questions, so please.
Thank you for that awesome presentation and for the amazing work y'all are doing there. Some of what we heard earlier in the meeting was that the communities that are most at risk are not receiving the messages and not receiving the alerts. And I'm just wondering, how do y'all determine if this message is getting to those communities?
Yeah, so we are going to evaluate this whole thing, but we chose to use, so I have kind of an extension ask appointment. We chose to use the extension type model of the trusted messenger. So that's working through the state health department to the county health officials, to extension agents, and also tourism extension agents as well. And we're going to get through the summer and look back and see if it's made any difference. But we need to think about this, I think, a little bit more about how it's actually getting down to the people.
Hi, thank you for the talk. I was wondering, when you went back to the map of the different heat index values for the different climate regions in North Carolina, and you mentioned that the partners you're working with weren't interested in maybe using the thresholds that were defined nationally or by scientists. So I'd love to hear just a bit more of like the back and forth process of how you came to the different heat index values, particularly given that you have like a diverse range of topography and
so what we did
conditions.
is we looked at the emergency department data, and we looked at anybody who was admitted for a heat-related illness. And these data are hard to come by, and we don't have all the demographic information tied to them, and it took us 10 months to get the data in and of itself. So we just went with one value for the entire season. We know that heat season in May and June, there might be more hospitalizations because people aren't acclimated to the heat yet. But we just wanted to give our partners an idea of when they might start seeing the impacts in terms of hospital visits. I wouldn't say they're not interested in using the National Weather Service criteria, but we know that it's too high to reach. It's too high for certain vulnerable populations, and they'll say it too, that by the time we hit a heat index of 105, 106, 107, they've already seen people go to the emergency department who are elderly or have underlying health conditions. We also see, and we get alerts every week of who showed up, and a lot of the data stripped away, but it's mostly men 18 to 44 who end up in the hospital. We have a big agricultural community. We have folks who can't access air conditioning, construction. It's a rapidly growing state. So those things don't always hold up either, but it's largely just an alert internally for them to deploy resources.
Is it a quick one? Okay, quick question, quick answer, please.
Hopefully. Yeah, well, I'm too short for this. But anyway, it really resonated when you said that there's not a blockbuster event to point to. I think like in Miami, that's something we talk about all the time. So I'm just curious, like what has resonated for electeds in terms of saying like this is a problem? Is it pointing to morbidity, mortality? Like how do you make that argument?
Honestly, it's overnight temperatures. So I didn't show the graph for North Carolina, but overnight temperatures have skyrocketed, and we would go decades without having an overnight temperature over 75 in Raleigh. And now it happens multiple times a year. And because we have such a strong agricultural community, we see the impacts on our crops, the public health. That one has actually resonated really well with electeds and government types. The general public, a little bit less so. 76 doesn't sound like something to be upset about.
Great. Thank you, Kathie. Okay. Next up, we're going to hear from Micki Olson from the University of Albany.
Hello, I'm so excited to be here. So I am a risk communication researcher. So this has been a really interesting couple of days for me. So I focus on what words and language we should use to talk about heat help people protect themselves. So this presentation is going to go over a project that focuses on how people understand information from the National Weather Service. But I try to make it applicable to anyone who's engaged in other public safety, public health, emergency management, as well as all of you who engage with the public from time to time when it comes to your science communication efforts, rather that's when you talk to the media or, as Bernadette said, with your grandma. But before I talk about our particular study and the findings, I did want to go over what we know about communicating about heat in general. And what we know is that organizations, in particular public safety organizations, they often communicate in a way that makes several assumptions about how people behave. And when these assumptions make their way into the messaging, that's going to make the message less effective. So here are some assumptions. First is that telling people about heat and heat dangers is going to lead them to change their behavior. That's not true. Second, that at-risk individuals will recognize their own vulnerability, which will lead to concern and awareness. Again, not true. Third, the benefits of heat advice are commonly understood and taken seriously. Not true. And fourth is that the caretakers of vulnerable groups have the capacity and training to engage in heat reduction measures. Largely not true. So last year, we conducted a study looking at how the National Weather Service communicates on social media in particular to see, are these assumptions present in their messaging? And if you scan this QR code, that'll take you to the journal article, which I can also send you directly if it's still behind a paywall. And we found that yes, these assumptions are present based on how they're communicating on social media. Again, a channel that they attempt to communicate directly to the public. But what we also found is that they communicate with a lot of what's called jargon. So jargon is technical or specialized language that relates to a particular context or serves a particular purpose for a homogeneous group, yet is rarely used or readily understood outside of those situations, right? So what we found is that the Weather Service communicates in a way that assumes that words like heat advisory and heat index, these mean something to people. Do we think they mean something to people? Well, we don't know. Think about the language that you use in your own disciplines and if that's going to be understood outside of it. I'll be completely honest, I didn't understand a lot of what was going on because I'm not a climate scientist, right? It's not because I don't have the capacity not to understand, but because we have different training, right? We have different experiences. So the things that you think that you use words you talk to one another with are not necessarily going to be understood when you move outside of that group as well. So this is what our project focuses on, is how do people understand the information that they get from a key public safety organization in the United States, right? So I structured our research questions following those assumptions that I just outlined. So how do people understand information about the hazard, the different alerting levels, how it's described and the impacts? How do they understand the vulnerability information that they're given? Again, that's been a huge topic over these past 3 days. And then also, how do they understand the protective action, what we call guidance that they're given? So to answer these questions, we conducted 16 virtual focus groups all across the United States. We recruited our participants through advertisements on Facebook. So we had about 6 to 8 participants in each group. So we're talking about a total of 121 people. So these lasted 90 minutes. Again, they were virtual, and then participants were compensated for their time upon the end of the focus group. So here are the locations where we conducted, where we solicited participants. You can see we tried to capture all different types of heat that people experience. So we have the dry heat of Phoenix to the humid conditions of Houston, up north to the west, and everything in between. So we took a really methodical approach in where we were sampling, both climatologically as well as demographically, right? We wanted to get a lot of different people's perspectives as well and hear from them directly. So we tried to take a really systematic approach with this. So we used it's called a semi-structured approach, meaning that we asked a set of questions, but then we asked follow-up questions based on what people said and what was interesting. So we created 5 example tweets based on our prior analysis, and we used these merely as a vehicle to elicit people's thoughts and feelings and opinions on the information that's contained in that tweet. So for each of these messages, we asked them 3 primary questions. What are your thoughts about this message? What stands out to you? And is there anything you find difficult or confusing to understand? So I'm actually going to skedaddle through 2 slides because I actually want to leave more time for questions. All right, so the first result I want to talk about are how do people understand the different levels of alerts that they get from the Weather Service? The most common being heat advisory and extreme heat warnings. We use the word extreme because this is the language that the Weather Service is going to be changing to at the end of the year, so we wanted to mirror that. So when people are told that there is a heat advisory in effect, what does this mean to them? Well, that's just that's giving me advice, right? It demands my attention, so I'm more cognizant of the conditions outside, but that doesn't necessarily mean I'm going to change my behavior in any way under a heat advisory. Whereas a warning is more severe, it's more concerning, it means do not go outside. These are very dangerous conditions. But there was also a group of people who didn't know what these meant. So if they were told they were under a heat advisory, what does that mean? What is it going to feel like? And then in response, what am I supposed to do with that information? How am I supposed to protect myself? This wasn't known. So overall, both levels of alerting all across the country, people thought they were really uninformative, right? Because they don't know what it's going to feel like under advisory versus a warning. And this is the information people actually need to make decisions. So we recommend that instead of just telling people there's advisory in effect or there's a warning in effect, giving them the specific temperatures or letting them know the conditions, what conditions will feel like, are going to help them make better protective action decisions. So for example, one participant illustrated this by saying temperatures would help in understanding the differences between a heat advisory and extreme heat warnings are. Next is heat index, which we heard a lot about, which in humid conditions is a common way the heat is described. It's going to be a heat index of X degrees. So there was really a mix of knowledge about people who knew what heat index was and those who didn't. Those who did, I quote, know what it is, they were like, well, that's the feels like temperature, right? And this is something that we commonly hear. It's what it feels like. But why it feels a certain way, this wasn't as well known, right? So they were less likely to connect heat index with humidity, and they would name other factors like UV, if it's raining, as things that are going to affect the heat index, right? So if we think of heat index, again, it's the relative humidity and air temperature. That connection to humidity isn't known. And they're also unsure why high humidity is dangerous, right? We heard this morning why it can be, right? But people are unsure if it's particularly humid out, why they have to protect themselves any differently than any other day. So for example, we saw one participant, they said, I don't know what peak heat index values mean. I think I've heard it referred to as the feels like temperature, but I'm not sure. So again, we hear that feels like language pop up, but it kind of seems like they're guessing, right? Based on that last sentence. We heard a lot of people say, I think this is what it is, I'm not sure. So we heard a lot of uncertainty throughout our focus groups. So overwhelmingly, people said, don't tell me the heat index, tell me this is what it feels like outside, right? They want that feels like language. This is going to mirror what they see in their weather apps that we all have. But also what's important is when you tell them it's going to feel a certain way, make that connection to humidity clear too. It's going to feel a certain way because of the humidity. It's going to feel like X degrees because of the humidity is really important. Next is how we describe heat impacts. And impacts are how is it going to affect me, the individual, and my body. And this is commonly, we hear the word heat illness, right? So when people were asked, what does heat illness mean? People most commonly listed the conditions of heat stroke and heat exhaustion, but they also listed things that were less severe, like sunburn, as well as perhaps less attributable to heat itself, such as depression or headache, right? So these less common, perhaps. Many hadn't seen the term heat illness before, though. So to them, they're like, what's actually going to happen to me? I have no idea. What are the symptoms I'm going to expect? This was much less known because heat illness was a new term. So we recommend, because as we heard this morning, it's really a spectrum too, that if there are certain illnesses that are of most concern, that those should be provided, as well as the symptoms, right? People aren't always going to know what to look out for both themselves and especially for other people. Next, we were interested in how vulnerable groups are described, with my first question being, well, what about the word vulnerable, right? So many of us, we have our own academic definitions of what vulnerability is, but what does the public think about the term vulnerable? So many said, well, it's factors of me and my body that make me vulnerable. So again, my age, if I have any pre-existing medical conditions, but as we've heard consistently, there are also factors outside of me and my body that make me vulnerable. Where I live, my income, right? So as a term itself, people didn't see it as offensive, but for consistency, especially in the federal space, agencies like the Centers for Disease Control, they're moving away from the word vulnerable to instead focus on people who are at increased or higher risk. So focusing on, it's called person-first language. Next, this is a group that we've heard a lot about, are the elderly. But who is elderly, right? When you ask people, who is elderly? We heard as low as 50 to as high as 80, upwards to 90. So we're talking like a 30, 40 year range here of people who thought of the elderly. Also, we've heard, and this was, we found in our focus groups, people who are older, so we're talking like probably 60s, 70s, they're like, well, I'm not elderly because I'm still mobile. I'm still independent. I don't have any pre-existing conditions, right? So if you just say elderly are at risk, first, there's going to be a huge range of people that is concluded and with many different interpretations, as well as people not seeing themselves at risk. So to help people personalize their risk, especially those who are older, is rather than saying elderly, give the specific age range that needs to be more cognizant, that needs to be more careful. So if it's those who are 60 plus, then say those 65 years or older. Not go. Oh, that's because I'm hitting the laser. Okay. Okay, and so then the final type of information I would like to talk about is how we describe the protective actions people are supposed to take. And so I'm going to talk about one particular phrase, but this applies to many phrases and types of information that I see out in the world, such as stay cool, beat the heat, take heat safety precautions. People see that, they're like, okay, great. What are you asking me to do again, right? So people don't know specifically what to do under these vague or unspecific protective action statements. And when people don't know what to do in response to a message, they'll have to fill in the gaps. And they might do something that is either contrary to what is recommended or might be less effective. So I have other data where people say, well, I would eat a lot of cucumber or watermelon, which is great. It's delicious. It has lots of water. But perhaps it would be more efficacious if they drink more water throughout the day, right? So maybe rather than staying hydrated and people are like, I'm just going to eat some cucumber, maybe tell them, drink this many ounces of water a day. Make it more specific. All right, so I'm not going to go through this, but we are welcome to take a picture of these recommendations, or I can provide you the slides. So we have what is the current language that is used, and then what we recommend instead based on our messaging. Again, anyone can use this, whether you're in public health, public safety, or whether you're just scientists who are trying to communicate the importance of heat and why people should stay safe. These are overarching recommendations that anyone can use for when you engage directly with the general public. If you have any questions, I'm very happy to answer them. And here is my contact information. Thank you.
We do have time for one question.
Thanks for the presentation. So I had a question about the messaging around feels like temperature.
Yeah.
So you're talking about heat index, and I think since 2022, the National Weather Service is now also providing wet bulb globe temperature. So there's like a separate map, and those are different in terms, one considers radiation, the other doesn't. So like what do you, well, when you say heat index for feels like, it's like shaded conditions.
Mm-hmm.
So how do you have any thoughts about like these two different metrics now being produced and what that means for the messaging?
Yeah, I think that I don't have data on it, but I think wet bulb globe temperature will be the same, if not, I guess, lower performing in terms of people knowing what it is. Mm-hmm. I think if it's something that you want to use, you could explain it and say this is a temperature that we use based on then how it's calculated. But I also think people make the assumption that the public needs to know all the information that we have all the time, which is, yes, you do, but you also need to translate it, right? They don't need to know everything. They need to know the most important pieces of information, how hot it's going to be, where, when, and how they can protect themselves, right? So those are really key. So they may not even really need to know the specifics of the wet bulb globe temperature, just that it's going to affect them and they're unsafe.
Thank you.
Mm-hmm.
Maybe you two can connect after the session. Thank you, Micki. All right, next up, we have Malini Roy from the University of Arizona.
Hi, everyone. I'll take a bit of a different lens. I'm Malini Roy. I'm a planner and currently a postdoc at University of Arizona with the Southwest Urban Integrated Field Laboratory, funded by the Department of Energy. And I'll be presenting some work done by a host of people led by Drs. Slat Keith and Sarah Miro. I should have asked how this works. Oh, right. Thank you. So my focus is plan evaluation. So you might ask, why plans? What do they tell us? What are they communicating? So plans are essentially they're documents prepared by a variety of organizations, government, non-government organizations, and they put together community input experiences with technical data and essentially come up with a long-term vision of what a community would look like in the long term. 5 years, 10 years, 20 years, and a roadmap for making that vision happen. So really our audience is the planner and the decision-making makers for a certain community. And we work with several communities in Arizona, helping them as well as learning from them on how heat resilience planning can improve in the future. So one of the main things that I'll focus on here is coordinated heat resilience. And the whole idea is that cities now prepare a whole host of plans. There are parks plans focusing on parks, transportation plans, housing plans, as well as more holistic, comprehensive plans looking at, a different land use and all sorts of issues. And the idea is that all of this together shapes the degree of heat risk in communities, right? And heat is shaped by all of these different plans. For example, we've heard a lot about housing, right? Take public housing, for example. The location of housing might be shaped by a housing plan. The distance between that housing to a park might be something that a comprehensive plan or even a parks plan has some say over. Transit to that public and from that public housing is something that a transportation plan might deal with. So what we want to argue is that there's a real need to look across these different types of plans and bring them together and get them to talk to each other so that we have a holistic understanding of, how do we make this one site or all of these different types of infrastructure more resilient. And unfortunately, past research tells us that so far we haven't done such a good job with making them coordinated. We take three different lenses or three different dimensions on this. One, are these different plans talking to each other explicitly? Are they mentioning these other plans? For example, is a comprehensive plan mentioning a climate plan and vice versa? Second, we'll look at the quality of plans, and by that I mean these 7 principles which have been argued in literature to further actual change, moving from policies and these ideas to actual action. And that includes goals, fact-based strategies, implementation monitoring, coordination, both horizontally and vertically, inclusive participation, and of course that's something that we have talked about and is important to us, and of course uncertainty, another major theme from the physical sciences parts in this workshop. And the third lens is policy attention. So moving from between plans to components within plans to policies within plans. And we're taking a spatial approach to this policy analysis, really looking at are plans, mitigating hazards spatially across the city, but also are these different plans approaching it in a more integrated way. All right, so that's the theory behind it. I'll focus on 7 cities across the Arizona. Again, with all of its issues that we have talked about here, I still use land surface temperature as sort of a proxy for how the heat compares across these 7 cities. They're very different in terms of size. There are cities like Phoenix, which we have talked about a little bit. There are also very small cities like Nogales, which is like 18,000 people. And our goal is not to compare across the cities. This study sort of serves as a baseline so that we can then go into each of these cities and work with planners in these cities to improve heat planning. I won't get too much into detail, but for the explicit references between plan, we use social network analysis. For plan quality and plan integration, we used plan content analysis using usual, agreed upon content analysis techniques. We analyzed 21 plans and 804 policies across the whole urban corridor. For plan quality, it was a binary assessment. For peers, we selected policies, scored them +1 if it was reducing heat risks or vulnerability to heat, -1 if it's increasing vulnerability to heat, 0 if it's neutral, and U if we don't know what the impact is. Then we would assign scores to census tracts and map the net scores from all policies by census tracts. Because we were specifically interested about social equity, we also correlated them with social vulnerability indexes. All right, so what did we find? First, explicit coordination between the different plans. So the first thing that I wanted to point out is the top row of cities are smaller cities. And it's very easy to tell because those are fewer plans. So each circle represents a plan. The lines between the circles represent references. And if you look at Tucson, Flagstaff, those are bigger cities, lots of plans. The key takeaway here is the central red, let's see if I can, so these ones are the comprehensive plans in each of these cities. And in all of these cities, the red comprehensive plans are arguably older plans, but also they're the ones that are referenced the most. So by extension, what that means is that they have a lot of influence on what other plans are doing. I will mention here that Arizona state law does require communities to have comprehensive plans. All right, so from there, I'll go into principles of effective heat, findings around those 7 principles that I talked about. So the graph to your left shows you overall how the network of plans in each of these cities are doing. For 4 of these principles I'll talk about. So these are the ones that the cities are doing okay on. So there is some variation. Some plans had fairly low plan quality, 34%. Others were like 76%. But overall, implementation monitoring, public participation coordination was pretty good. They were doing pretty well on this. Goals, basic things like stating plan purpose, stating goals. Most plans had those. But if you look more closely at, heat risk reduction goals and heat equity goals, very few plans had those. And then more concerningly, we found real gaps in the fact base. Now, again, tying it back to what we have been hearing today, a lot of the physical sciences and the drivers behind heat would be incorporated in these sections in the plans. And we found that information on heat vulnerable populations, mapping existing heat, projected heat, even capacities like vegetation, forestry, very few plans actually had those. And most importantly, probably for this audience, not a lot of plans actually had information on uncertainty. And I think that does have something to do with the fact that it's very difficult to visualize, communicate to everyone. We as planners do like maps, so it'll be great to have an uncertainty map at some point. But yeah, those are sort of the gaps there. And then finally, consistent spatial policy and whether consistent spatial policy is actually also advancing social equity. As I mentioned, we collected 804 policies, which compared to a lot of other places, it's a lot of policies. 67% of those policies were actually scored +1, meaning they're reducing heat, which is not bad, right? And if you even go into each city, most of these cities, majority policies are reducing heat. And you think, well, that's pretty good. That's not bad. But then if you look at the maps underneath these, let's see. So these, you'll start to find that there is a lot of variation within, between census tracts within these cities, meaning all of these great policies don't apply everywhere. So naturally, the next question are these differences by census tract associated with social vulnerability, physical vulnerability? And so there's a lot of number, and I'll highlight what we found was interesting. So net scores here net scores actually are representing the degree of consistent and integrated attention on heat mitigation. And what we found was net scores were not actually correlated with CDC socially vulnerable index. It was statistically significantly correlated with the new Arizona-based social vulnerability, which is more detailed in terms of incorporating pollution, tree canopy. So I think just to point out that it is important to understand social vulnerability, which is more local. And then net scores, again, were correlated with mean land surface temperatures for 2023, meaning it does feel like in all of these cities, more integrated hazard mitigation is allocated towards social vulnerability and physical vulnerability areas. But then if you weight those net scores by total policy, somehow the relationships are inversed. How does that happen, right? So then we are right now actually starting to look at typologies within these different cities. And we found that what we see in Phoenix and Tucson, the bigger cities, isn't really what we see in Flagstaff, which is more hilly, relatively cooler, doesn't have those blockbuster events as was said. And even more different in Nogales, which is a very small town. Their main focus is migration and borderline security. So I'll, stop there with the final summary of opportunities that I found. I'll stress that I think there is really an opportunity to think about these complementary methods to analyze plans and using plans as a metric for understanding what public policy is looking at in terms of important things around climate and heat. In Arizona specifically, we found a real need to transition for recognizing that it's hot, which it is, but we need to move beyond that and really focus on who's vulnerable, where do these vulnerable populations live? And there are obviously more detail that one can go into in terms of exact vulnerability variables. There's also lack of understanding on capacities, especially grassroots capacities, but also urban forestry, natural capacities. We looked at the network of plans and we found that, the general plans were central, but not so much other important plans like climate action plans, hazard mitigation plans. And so one of our recommendations is to bring those climate action and hazard mitigation plans more central. And making sure that the uncertainty information and the climate change information, specifically things like heat projections, could be brought more into these comprehensive plans and parks plans and transportation plans. And I think climate action plans being more central will be key to having more of an influence on the network. Mitigation attention relatively is high, but spatially inconsistent. And so there's an opportunity to direct more, mitigation policy attention systematically, so it does feel like in some neighborhoods it's highly vulnerable, there is more attention, in others not so much. So there is a need to more systematically look at how do we give more parks, give more waste heat reduction incentives to these more vulnerable areas. And then finally, general plans are key. So let's make sure that they're high quality plans. Arguably our general plans for older plans, they're now being updated. So currently, we are working with planners and decision makers who are working on general plans and other plans, including Shaylin, who's here, and really trying to improve the fact base and the input that gets incorporated into policies in these general plans. I'll stop there, and if there are questions, I'm happy to answer them.
Thank you, Malini. That's great. We do have time for one question. I'm going to take one from online, if that's all right, from Keith Dixon, our moderator on day one. On the topic of communicating uncertainty, do you have suggestions on how to better bridge the jargon gap between climate scientists and planners?
I think we like visuals. I think that works best for us instead of numbers. I know as academics, we do like to do correlations and, that sort of statistical stuff. But ultimately, it'll be great to have a visual portraying uncertainty. But I'll also mention that I think one of the key things around uncertainty is how do we move our understanding of uncertainty to strategy? I think that's also another area that we could use your help with.
Thank you again, Malini, for a great talk. And our final speaker of the session is Maggie Allen from NOAA.
All right, thanks for sticking around. I know I'm the last speaker, I think, of the whole workshop and also keeping you between here and lunch, so I'll try to keep this fairly brief. So I'll be talking about how NOAA and other federal agencies are working to advance heat resilience, specifically with our equity pilot projects. I work in NOAA's Climate Program Office. For those of you outside the US, the NOAA is the National Oceanic and Atmospheric Administration, and it's part of Department of Commerce. Let's see if, okay. So I don't really need to dwell on why heat is bad or why addressing it is important, but just for the context of this presentation, obviously we aren't doing enough to prevent heat impacts. And some of those reasons are because the impacts of heat are often invisible, delayed, or poorly quantified due to lacking data and studies, as well as methodological issues. Heat governance falls between the cracks at all levels of government, like we've been seeing during this workshop. And obviously, heat affects marginalized groups the most, which lessens the pressure of many decision makers to act. And finally, as we just kind of talked about, many communities don't have heat action plans or long-term planning in place, or maybe they just haven't tested those plans. And to address some of these many issues of heat and to fill those gaps, there's the National Integrated Heat Health Information System, or NIAS. NIAS was launched in 2015 by NOAA and the Center for Disease Control for a coordinated approach to heat resilience. It's transdisciplinary and works across governmental agencies and also involved many non-governmental partners like health officials, elected officials, energy companies, universities, and museums. It also works across timescales to bridge long-term heat mitigation and short-term planning, and it supports and implements the White House Extreme Heat Interagency Working Group. So some of the things that NIAS does is, well, in general, the program manages interagency coordination and planning, and it's hosted in the office I work in NOAA, the Climate Program Office. Some of the things that we coordinate overall together, one of those is the National Heat Strategic Plan, which is actually coming out. It should be coming out next week, so keep a lookout for that. We also host heat.gov, which I believe has been mentioned a few times here, which is kind of the federal one-stop shop for all things heat. Out of heat.gov comes the Heat Beat newsletter, which comes out about every week or so during the hot months and then a little bit less during the colder months. And we also have a Twitter account of heat.gov. We also have many interagency working groups, various funding priorities, forums, and communication efforts. An example is we host a meeting every year called NIAS National, which was just hosted in April. It's virtual, so it'll probably be coming up next year again around the same time and is free to attend. All right. A big thing NIAS and NOAA have been doing are urban heat island mapping campaigns, which has been going on since 2017. Since then, over 80 communities have been mapped across the United States and 3 international cities. We also will map 16 more this year, many this summer, including 3 international cities as well. And I just wanted to show here, since we're in New York City, here are the results of the New York City Urban Heat Island Mapping Campaign. Which you can see, obviously, Central Park is the coolest area, and it's hyper-local, so citizen scientists went out and mapped areas in most places by car. I assume New York might have had some bikes or walking as well, and it shows at a hyper-local perspective what are the most vulnerable neighborhoods and communities to extreme heat, and how that often correlates, obviously, with social vulnerability and other factors. We just heard about the plan integration for resilience scorecard for heat, which was something that did come out of some funding because NIAS also provides technical capacity for local action. NOAA and other programs within NIAS provide funding for researchers to develop targeted heat mitigation strategies by combining results of those by doing things like combining results of those urban heat island mapping campaigns I just mentioned with some ongoing planning efforts. So in addition to the PERS scorecard, there's also things that have come out of NOAA funding, such as heat vulnerability indices and community resilience estimates that also involved census, as well as some research to better understand and attribute the processes for driving heat and other extremes. And then one of the things we also just announced were 2 centers of excellence that came out of funding of the Inflation Reduction Act from the Biden-Harris administration. So one of those centers is called the Center for Collaborative Heat Monitoring. That will be hosted out of the North Carolina Museum of Life and Science in Durham. There's also a variety of other science centers around the US that will be kind of technical and resilience hubs doing that same kind of work, which is mostly community science. So that center will be supporting community science-led data on extreme heat so that communities can better observe, monitor, and evaluate the factors that are influencing heat risk at a local scale. And then the other center is the Center for Heat Resilient Communities, which will be hosted by the University of California of Los Angeles, UCLA, also led by the 2 Arizona universities, Arizona State and University of Arizona. Keith and Sarah Muro are co-PIs on that project as well, who we just heard about. And that center will be determining the best strategies for mitigating and managing local heat, leveraging federal investments to reduce heat risk, and developing data-driven solutions. So that center will be really focused on policy, practice, and assessment. They'll be helping communities do things like apply for federal grants, helping them develop things like heat benefit cost analysis, and developing better governance for heat. And so all of that kind of leads us into the main thing I want to talk about today, which is the climate equity pilot projects NOAA did in the fall of 2021 and how that resulted in heat exercises. So a few years ago, NOAA and some state local partners hosted these climate and equity roundtable events around the country to better understand how underserved and vulnerable communities can develop better climate adaptation strategies to enhance resilience to various climate hazards. So this focused on all sorts of climate hazards such as flooding and sea level rise, but extreme heat was the focus of 2 regions, the West and the Southeastern Caribbean. And there were 4 communities that did these pilot projects in those 2 regions. And I'll talk about those in a minute. So the extreme heat equity pilot projects in particular built on those prior urban heat island mapping campaigns I mentioned. They were developed by local NOAA teams as well as members of the NIAS interagency group with National Weather Service deeply involved. Community-based organizations were literally at the table of these events, kind of driving the direction and the solutions of these pilot projects. And it was really focused on place-based solutions, climate equity, and new model practices. So the goals of these pilot projects were to promote heat resilience and equity at the local scale, to empower communities to recognize and implement local solutions, and to create and expand local partnerships to build heat resilience and expand equity. Community-based organizations were there, like I said, really representing their constituents throughout the process. So there were 4 steps for these pilots. They were engagement and listening, citizen science awareness, tabletop exercises, and local action and a resulting community of practice. In the interest of time and just what we want to focus on now are the tabletop exercises, which are informal group discussions that are centered on an actual or hypothetical situation. So what do these tabletop exercises look like? So the NOAA team and other folks on the planning committee, which, like I said, consisted of people on the ground in usually sustainability offices and things like that in those cities, as well as community-based organizations, developed a situation manual, and that guided the exercise. And these exercises were over 2 days. The first day focused on event response, where folks overviewed the expectations of the day. The weather forecasting offices of the Weather Service were there to kind of set up the scenario and the forecast, and what was going on in terms of extreme heat. There were discussions of information and roles. People went out over impact scenarios, and they identified gaps and priorities. And then day 2 really looked at heat into a longer-term climate context, so for longer-term planning. So there were more discussions there on those gaps and opportunities, and discussion and planning to address those gaps, and then it wrapped up. So we had those 2 days to really focus on both short-term and that long-term planning. So the communities involved in these 4 tabletop exercises last year were Charleston, South Carolina, Las Vegas, Nevada, Phoenix, Arizona, and Miami-Dade County in Florida. So again, those are 2 communities in the West and 2 communities in the Southeast of the United States. So just to focus on one as an example, we had Las Vegas, which they called Withering Daisy. And for most of you do probably know that Las Vegas is a city that routinely deals with large events and lots of crowd management, and they're pretty good at dealing with emergency services. but they did identify a need for coordination and of services in response to extreme weather events. They also so as I said, they had many different participants involved. So people came from all over the Vegas area to participate in this tabletop exercise. As you can see here, we had everyone from a casino showing up to a community-based organization called Make the Road Nevada. Federal partners were there like FEMA and public schools, Regional Transit Authority, climate centers, the climatologists, et cetera. So lots of diverse participants. And as I said, Las Vegas obviously does have a lot of deep experience in emergency planning for large events, but they knew they needed a more regional heat plan and clearer authority. They wanted something like a heat officer, which only a couple other cities have, and that they wanted better long-term planning to help residents cope with more chronic high heat. So things that resulted from this tabletop were a California-Nevada adaptation program launched the Southern Nevada Heat Resilience Lab that convened organizations working on heat. Las Vegas was awarded a grant that includes extreme heat risk planning. They installed bus shelters that provided better shading, and the city and county expanded tree planting efforts for heat mitigation. So lots of great things did result from these tabletops. We also learned some valuable lessons. Obviously, pilots evolve existing programs and existing equities. We learned the value of building connections within each city, yes, but also across the cities as well as between NOAA and local organizations. It also built capacity and authority. We realized, of course, that heat governance, or lack thereof in some cases, varies greatly from place to place, whether it's working in a city, a county, or a tribal nation. And obviously, we also realized the importance of involving community-based organizations, as they can help the federal government better reach at-risk communities and build relationships there. And stepping back as well, the pilots and exercises were very flexible to meet the needs of these cities. The cities did a really great job at hosting these face-to-face exercises, and all NOAA really did was help facilitate communication and build the tabletops. But the goal was to empower those cities to move forward themselves to meet their own self-identified needs. So just ending on some next steps from these tabletops and all the other work we've been doing. So we've recently published 2 documents on heat.gov. These have directly resulted from the heat tabletop exercises. The first one is an Introduction to Heat Tabletop Planning and Coordination Guide, which can help any community design their own tabletop on extreme heat. And that will hopefully inform improvements to preparedness, response, and long-term resilience. This is a deliverable report and a standalone guide that any community can use to develop their own tabletop exercise. We also published a maturity model for heat governance, which is a way for leaders and decision makers to evaluate their own heat governance and kind of where they stand along various dimensions. I won't get into it. The maturity model has 10 different dimensions that kind of measure where a community may stand in heat governance. For example, we have partnerships and networks where someone can look at where they are on things like coordination, inclusivity, event preparedness and response, and public communication. All this is explained in that guide. On the website, there will also be soon results published from case studies we did where we talked to various cities, walked them through the maturity model, and asked them to assess themselves where they are on heat governance. So you can see soon how different cities have rated themselves, ranging from Phoenix, which is very, maybe considered more prepared in some ways on heat governance, to other cities that maybe don't have kind of that coordination in place and institutions in place to advance heat governance. And there'll also hopefully soon be a survey where any community can go online and take it themselves to kind of get a report to where they might stand on heat governance. So all these things are forthcoming as well. And then we also hope to run more tabletop exercises to continue this work. We do have an in-person tabletop coming up next month in Oklahoma City that we've been working on, and there'll potentially be 2 more later in Scranton, Pennsylvania, and Seattle, Washington. We're also about to publish a challenge.gov competition, which is a way for communities to easily apply for federal government money. And the 10 communities that may win these prizes will get $10,000 to $20,000 to run their own tabletop exercises. They'll basically write their own situation manuals and apply on challenge.gov, and then a group of judges will assess the best tabletop, the situation manuals, and then they'll get that money to run their own exercises. So hopefully that will be published the end of the month. We're still waiting on some final clearance, but we're excited to publish that as well. And then I just wanted to end with generally what more do we need to do as a federal government and as a federal landscape. We need to continue to mature with a formal mandate, heat governance, authority, and accountability. Federal assistance to communities should be better coordinated, increased, and complementary across agencies. And finally, gaps in impact data science and reporting should be addressed through research with a feedback loop to heat action. So there's a QR code to sign up for the newsletter, which I said comes out about every week, and it's very comprehensive. You can also, check out the website heat.gov, email us at nias@noaa.gov, follow us on Twitter. I didn't post my own email on here, but come talk to me if you'd like to learn more. And I just wanted to thank the whole team that has been doing all of this heat equity pilot report work. Thank you.
Thank you, Maggie, and thank you to NOAA for all this work in the stakeholder space and for supporting this workshop as well through the CAP program. Unfortunately, we don't have time to take any questions now. I have one sort of programmatic announcement, but let's first take a minute to thank all the speakers during this session. Thank you.